Hey guys, Mr. Backenberg here. In this video, we're going to look at plotting points in a coordinate plane. Before we get too far into things, we should talk about what the coordinate plane is. So the coordinate plane is made up of two axes, one horizontal axis and one vertical axis. And those axes extend in both directions forever and ever. This horizontal axis is your x-axis, and the vertical axis is your y-axis. And each of these axes really represent number lines that extend in the positive and negative direction. And what we're able to do with those number lines is map out some different coordinates within this coordinate plane by talking about specific x values and specific y values. And that's where we get the idea of an ordered pair. So a point is a combination of some x value and some y value written with a comma between them and parentheses around it. Now, x values, since the x-axis moves horizontally left and right, your x value will move you left and right. If your x value is positive, that means you're moving to the right, but if your x value is negative, then that means you're moving to the left, however many spaces. Now, your y-axis goes up and down. So if your y is positive, that means you're moving up a certain number of spaces. And if your y is negative, that means you're moving down a certain number of spaces. Now, this point in the middle where your two axes meet up, that has a special name to it. It's the coordinate 0, 0, and it's called the origin. Now, one other thing that happens in this coordinate plane, when we draw out these axes, it splits this grid up into 4 different regions, which we call quadrants. In the top right-hand corner, that's quadrant 1. And we typically number these using Roman numerals. Now, in quadrant 1, since it's on the right-hand side and above the x-axis, that means, as far as our ordered pairs go, that our x values are always positive and our y values are always positive. So every single ordered pair in the first quadrant has positive x values and positive y values. Now, if we move over here to the top left-hand side, that's quadrant 2. Now, because we went left, that means that our x value is going to be negative, but we're still up, so that means that our y value is going to be positive. So every single ordered pair in the second quadrant will have a negative x value and a positive y value. Down in the bottom left-hand corner, that's quadrant 3. Now, we're on the left-hand side, so that means we're dealing with a negative x value, but now we've dropped below that x-axis, so that means we've got a negative y value as well. So in the third quadrant, the x's and the y's are both negative. And then if we're down in the bottom right-hand corner, this is quadrant 4. Now, we're on the right-hand side this time, meaning that we've got a positive x value, but we're still below the x-axis, so we've got a negative y value. So in quadrant 4, the x's are positive, but the y's are negative. So in this example, I've got some ordered pairs plotted out on a coordinate grid, and we're going to determine their coordinates by looking at what we've got happening in the picture. So we're going to start by looking at point A. And the first thing we want to figure out is how far left or right we moved. That's our x value. So to get to point A, we moved left 1, 2, 3, 4 spaces. Since we went left, that means we're dealing with a negative x value. So it's going to be negative 4 since we went left 4 spaces. Then we want to figure out how much up or down movement there was. So to get to point A, once we go left 4 spaces, then we have to go up 1, 2, 3 spaces. Up means a positive y value, so 3 spaces up means the y value is 3. So point A is located at negative 4, 3. If we look at point B next, again, we're going to do our left and right movement first. So to get to point B from the origin, we go left 1, 2 spaces. So left 2 means negative 2. And then from there, we go down 1, 2, 3 spaces. So we have negative 3 as our y value. If we look at point C, we're going to start at the origin again. To get to point C, we have to count 1, 2, 3 spaces to the right. So we're going to have a positive 3 for the x value. And then we go 1 space up. So 1 is our y value. If we look at point D, to get to point D from the origin, we didn't move anywhere left or right. So that means we've got a 0 x value. But we went up 2 spaces. So that means my y value is 2. Our last point we've got is point E. So to get to point E, we go to the right 2 spaces from the origin. So the x value is 2. And then we have to go down 1, 2, 3, 4 spaces. So my y value is negative 4. Now this example goes the opposite direction. So I'm giving you coordinates for 3 different points, and we want to plot them out on this grid. So A is at the point negative 4, positive 4. So that negative 4x value means that we need to go left 4 spaces from the origin. So 1, 2, 3, 4. But then the positive 4y value means we need to go up 4 spaces. So 1, 2, 3, 4, up. So I'm going to put a dot where those grid lines intersect, and then I'm going to label my ordered pair. This was point A. Now, because we're on the left side and up, point A lands in quadrant 2. Now, if we look at point B is the ordered pair 3, negative 2. So from the origin to plot out point B, I need to go to the right 3 spaces, but then down 2 spaces. So again, where those grid lines intersect each other, I'm going to label that one as point B. Now, because we're on the right-hand side and down, that means point B is in the 4th quadrant. Then our last point, point C, has a 0x value. So I'm not going to move anywhere left or right from the origin, but we've got negative 4 as the y value. So I have to go down 4 spaces. And I'm going to put my dot right there, and this is point C. Now, point C doesn't really fall in any of the quadrants. It's right on the y-axis. It's on that separator line between quadrant 3 and quadrant 4. So it's not in either one of the quadrants. We would just say that it's on the y-axis. Now we're going to take this one step further. Instead of just graphing out individual ordered pairs, we're going to start creating graphs of functions. So we're going to graph out the function y equals 2x minus 1 using domain values of negative 2, negative 1, 0, 1, and 2. Now in order to do this, we're going to create ourselves a table of values. Now we're going to have some x values, and remember, your domain represents your x values. So we're going to be plugging in x values of negative 2, negative 1, 0, 1, and 2. And then what's going to happen is we're going to get some y value output answers. Now I'm going to throw a middle column in here where we're performing the actual operations. So that's when we're doing the 2x minus 1 with plugging in the specific x value. So the first x value that I'm going to plug in is this negative 2. So I'm going to take that and plug that in for x in my function. So we would get 2 times the negative 2 minus 1. And we're trying to figure out what this is going to equal. So 2 times negative 2 would be negative 4. And then if we subtract 1 more from that, we get negative 5 as our answer. So that's our y value output. Now what we can do with this is take this and turn it into an ordered pair. So because we plugged in negative 2 as the x value and got an answer of negative 5, that all goes together as one ordered pair. So I can take that and plot that out on my grid now. So the negative 2x value means I need to go left 2 from the origin, and then the negative 5y value means that I need to go down 5. So there's my first point for this graph. Now looking at the next x value, we're supposed to plug in negative 1. So in my function, I'm going to replace the x with a negative 1. So we get 2 times negative 1 minus 1. And now we're going to simplify this down to get a y value answer. So 2 times negative 1 is negative 2. And if I subtract 1 from that, we get negative 3. And then just like we did previously, I'm going to take this and turn this into an ordered pair. So we plugged in an x value of negative 1, and we got an answer, a y value of negative 3. Now that I've got this ordered pair, I should be able to plot it out. So negative 1 for the x value means go left 1 from the origin, and then down 3 spaces since we've got a negative 3 y value. So there's our second point for this graph. Now 0 for the x value, so we'd get 2 times 0 minus 1. 2 times 0 is 0, and if we subtract 1, we get negative 1. So that's the ordered pair 0, negative 1. With that x value of 0, that means we're not going to move anywhere left or right from the origin, but we are going to go down one space. So there's our third point. Now we're going to plug in an x value of 1. So 2 times 1 minus 1. Now 2 times 1 is 2, and if we subtract 1 from that, we get 1 as an answer. So that's the ordered pair 1, comma 1. So that means from the origin, I need to go right one space and up one space. And then our last x value that we were asked to plug in was 2. So we're going to take 2 times 2 minus 1. 2 times 2 is 4, minus 1 is 3. So that's the ordered pair 2, 3. So from the origin, I need to go to the right 2 spaces and then up 3 spaces. So these 5 points represent the graph of this function using those specified domain values. That's going to be it for this video. Thanks for watching.